Welcome back, guys, to another lesson in Algebra 1. Today's lesson is Unit 1, Lesson 8. We are going to continue our study with equations, but we are specifically going to do absolute value equations. And so today's lesson with absolute value equations, they typically are going to have two answers. And in the next lesson, we'll learn kind of a little asterisk to that. So our objective today is I know an absolute value can have two answers, but it also can technically have one or none. Um, and then the second objective is I can solve absolute value equations by breaking the equation in two. So we're going to have to break it into two components. Well, let's take some notes so we can know what that's about. So to solve absolute value equations, we're going to make sure the absolute value portion is isolated. And step two, we're going to rewrite the equation without the absolute value signs. We'll make one equal to the positive value and one equal to the negative. And I'll explain a little bit more about why that is, here in a second. And so step three, we're going to solve both equations. And then we'll write both solutions. Okay, so what is all of that about? Well, let's take a moment and remind ourselves about what an absolute value even is. So let's say that we have the absolute value of 6. You would have learned about absolute value, a few years ago in math, but it was probably something you did once or twice and then you just moved on. So it's the distance from 0. And the distance can only be positive. So absolute value of something is always a positive number. So the absolute value of 6 is 6, but it turns out the absolute value, whoops, let me erase that. I got a little carried away. The absolute value of -6, because it's the distance from 0, it is also 6. So when we go to look at these equations, it turns out there's two ways that you can get this answer, because in this case, this 6, we could get it either because we had a positive 6 in the absolute value or we had a -6. And this is how we're going to end up with two different answers. So in the next part, let's go ahead and look at some examples of what we mean. Okay, example 1 is, about the easiest that can be. We've got the absolute value of m is 11. Okay, well, there's two ways that this can happen, right? And we just talked about this up here with the absolute value of 6. We could have, 6 came from positive 6 or 6 came from the absolute value of -6. So what we're going to do is our first step is we're going to make sure the absolute value portion is isolated. And we can see that's the only thing over here on the left-hand side. So 1 is already taken care of. We're going to write the equation without the absolute value sign, and we're going to make 1 equal to the positive option and 1 equal to the negative option. So I'm just going to break this up into 2. I'm going to do my first option where m is equal to positive 11, and then my second option where m is equal to the negative option. So it's m is -11. And because this was already as simplified as it possibly could be, these are our two answers. There's nothing more that we need to do here. So I can just go ahead and write that down here at the bottom. M equals -11 or 11. And that is the easiest way to look at it. Let's make it a little bit more complicated with example 2. Okay, so example 2, we can see that we have, we have some more stuff going on here. We've got -5y in the absolute value symbol equals 25. Alrighty, let's go look at our steps. Make sure the absolute value portion is isolated. Well, there's nothing outside of this over here on this side, right? Like we have it equal to 25 and there's nothing on the outside of this. So it is isolated. This we don't have to address. Number one is already taken care of. So what we're going to do is we're going to rewrite the equation without the absolute value signs, and we're going to make one equal to the positive version and one equal to the negative version. So we are going to break this up into two. So my first one, I can just come over here in my first option, I'm going to leave it positive. So I'm going to remove the absolute value signs. I'm just going to put negative 5y equals 25. And this is just an easy one-step equation. We're going to divide by negative 5 and divide by negative 5. And so that's going to give me y equals negative 5. So that's one way that would give us this answer. Let's figure out the other part. So if we break it up into the second option, so it said we're going to do one positive and one negative. So this was the positive 25. Over here in the green, I'm going to do the negative 25. So I'm going to write my negative 5y. It's still the portion that's in here in my absolute value equals, instead of the positive 25, I'm going to write negative 25. Alrighty, so we can divide by negative 5 and divide by negative 5. This cancels and we get y equals 5. So our answer here is y can equal negative 5 or positive 5. And we can even prove it to ourselves. I'm just going to do a little bit of scratch work over here. You know, you don't have to write this down. This is just me kind of talking out loud. If I did the math here, I did like negative 5 times positive 5, and it's equaling 25. Okay, so negative 5 times 5, okay, that's negative 25. Well, if we did the absolute value of negative 25, that's going to work, right? So that checks out. If we did it, so that was the negative 5 option. Let's try the 5 option. So if we did the 5 option, it's negative 5 times 5, and we take the absolute value of that. So negative 5 times 5 is going to give me, oh, you know what I did? I accidentally, here we go. It's going to be negative 5 times negative 5. Hang on. So we're going to get the absolute value of 25, and you know, the absolute value of a positive 25 is 25. So I know I just repeated 25 about a million times, but I wanted to show you that, you know, this is why it works like it does. So I'm going to erase that and we'll go on to the next problem. Okay, we can step it up just a little bit more. So, you know, here we had just the variable. This one we were multiplying by negative 5, and now we can multiply it by something and we can add something to it. It's okay, we can just keep going. Okay, so this one, there's nothing more to simplify here on the left-hand side. It's just in the absolute value sign. There's nothing outside of it. We will get to ones where it's like this, where you see there's like plus 5 or it's times 4. So for right now, we can skip that step 1 where we are isolating to get the absolute value by itself. I'm just going to go ahead and break this up into 2 equations. So my first one, I'm going to do 2y plus 3 equals positive 15. And so this is a 2-step equation. So we're going to subtract 3 from both sides. This cancels. We get 2y equals 15 minus 3 is going to give me 12. We're going to divide by 2. And we get y equals 6. Okay, so that would be if it was the positive version, okay? But what if we needed to get the negative 15 version in here in this absolute value? Let's go ahead and do that over here. So 2y plus 3 equals negative 15, okay? Because remember, if we did negative 15, that would equal the, you know, the absolute value of negative 15 would give us 15. That's why we have to do the negative option. So let's go ahead and subtract 3. And we're going to do 2y equals negative 18. And we're going to divide by 2 and divide by 2. And we get y equals negative 9. And so if we kind of brought both of those together, the answer is going to be y equals 6 or negative 9. Those are the two ways to get either positive 15 or negative 15 in that absolute value. Alrighty, we're going to solve this one. This one, the absolute value portion is completely isolated. I don't see anything in front of it, and I don't see anything behind it, before we get to the equal sign. So we can break it up into our two equations where it could either equal positive 18 or it could equal negative 18. So let's do this. So my first option, we've got 3n plus 6 equals positive 18. And my other option is 3n plus 6 equals negative 18. So that's the two ways that we can get this to be true. Like there's two values that'll work here. So I'm going to subtract my 6 from both sides. I get 3n equals negative 24. I divide by my 3, and I divide by my 3, and I get n equals negative 6. Alrighty, let's do the positive version. So it's now minus 6, minus 6. That cancels. We get 3n equals 12, and we divide by 3. We divide by 3, and so we get n equals 4. So notice you're going to see something here. Like when we started with these easier options, it was, the positive and negative of, the same number. So we had negative 11 or positive 11 or negative 5 or positive 5, but it's starting to get a little bit more complicated. Like we got 6 or negative 9. And then this one's going to be, 4 or negative 6. Let's go ahead and write that. Here we got n equals 4 or negative 6. Alrighty, now we're finally going to get to one where it's got something outside the absolute value. Okay, so this one has something outside of it. This one has something outside of it. This one does, and this one does. Okay, so these ones we're going to have to incorporate that step one that I skipped on the first 4 examples. So our step one, we've got to isolate the absolute value portion. So to do that is just like we're just going to treat this all as one thing, this absolute value, and I'm just going to subtract this 5 from both sides. And so I bring down, that absolute value of x equals 9 minus 5 is going to give me 4. And now that I have my absolute value portion isolated, I can break it up. So I can do my one equation. It's going to be x equals positive 4. And there's nothing more to do with that one. And I can do my negative version where it's x equals negative 4. So when I write my answer, both of them together, it's going to be x equals, positive 4 or negative 4. So that wasn't too bad, that particular one. So what happens when we have something outside of it where it's in front of it, like a coefficient here? Okay, it's not too bad. This when it's in front, I mean, it's like the distributive property, like we're doing, 4 times whatever this y is. So if it's multiplying, we can divide by 4. Boom. And we get absolute value of y is going to be 32 divided by 4 is going to give me 8. So now we can break it up into our two equations. So, option 1, we got y equals positive 8. And then over here we have option 2, where y equals negative 8. And so our answer is nice and easy. We got y equals 8 or negative 8. Okay, so we can take it and we can expand on this a little bit more. So we have something on the outside, and then we can combine it with something on the inside, and we're going to do all of our steps. So our first step is to get this absolute value portion by itself. We can't break up this absolute value portion until everything, all the other numbers are on the other side. So we're going to subtract 2 from both sides. And so we can bring down this part. It's going to be absolute value x plus 3, absolute value sign, equals 11 minus 2 gives me 9. So remember, whatever's inside here, it could give us a positive 9 or it could give us a negative 9. And so we have two ways that can happen. And so we're going to do the positive version and the negative version. The positive version is x plus 3 gives me positive 9. And the negative version is x plus 3 gives me negative 9. Alrighty, so let's solve this. Well, it's x plus 3, so we're going to subtract 3. That simplifies, and we get x equals negative 12. Alrighty, let's go solve the positive version. So we're going to subtract 3 from both sides. That cancels, and we get x equals 6. So there are two solutions, 6 or negative 12, that will work in this particular inequality. Okay, last but not least, we've got 18 and we've got 6 on the outside. And so we've got to get this by itself, like we've got to get that 6 removed, and then we can break it up. Okay, so I'm going to simplify this and get it to where it's just my inequality. So I'm going to divide by 6 on both sides. That's going to give me absolute value of y minus 2 equals 3. Now that I have my absolute value by itself, I can break it up into two equations. So I can do equation number 1, where it's y minus 2 equals a positive 3. And I can do the negative version, where it's y minus 2 gives me negative 3. Okay. I can add 2, and I can add 2. And so one of my solutions is going to be y equals negative 1. And I can solve this one over here. I'm going to add 2 and add 2. And I get y equals 5. Let me just do a little scratch work over here just to remind you why the heck we're doing it this way. If my equation is 6, absolute value y minus 2, absolute value 18. If I substitute, say, a negative 1 right here, so I got 6, absolute value negative 1, minus 2, absolute value equals 18. Negative 1 minus 1 is going to give me negative 3. And when I do the absolute value of that, that's positive 3. And 3 times 6 gives me 18. Okay, so that worked for that negative answer. I can substitute 5 in here, and I can show you this is why we're doing this. Okay, so why we have to have two cases. Okay, so let's say that we did the positive 5. And so we did 5 minus 2. Well, 5 minus 2 is going to give me positive 3. And it's still 6 times 3 gives me 18. So we were solving it both ways to make the statement true. That's why we have two answers on all of these ones on this page, where it's 5 or negative 1. Both are the solution for this absolute value equation.